Alright, so how many indefinite integration problems can we do in 7 minutes? So we're seeing this pattern. So what about this one? See if you can see this pattern with this problem. So see if you can find 1 over x minus 1 dx. Got an answer? So let me ask you this question. Is this the derivative of this? Is this the derivative of this? Like, this is really clear, isn't it? Therefore, this thing should be answered really quickly as ln of what? X minus 1 plus c. Similar one. This is what we're doing, asking ourselves this question. Is the numerator the derivative of the denominator? So here's the question. Find this, please. 1 over x minus 5 dx. Chloe, what'd you get? Why is that true, Killian? Right, that this is the derivative of this, so it tells us we're going to go straight to that, doesn't it? So the idea here is to see this in our heads so many times that it just starts to become more obvious. So here's another one. 1 over 3 minus 2x. So this one's not quite as easy, is it? So how are you going to solve this? What are you going to do here? Sure, I'd use u substitution. U equals what? 3 minus 2x. Good. Du dx. Negative 2. See if you can skip all the way over and see what dx equals. Can you see it? What is it? Du, right. Over negative 2 equals dx. Now we can just substitute, can't we? Dylan, is that good? So we rewrite it like this. We write 1 over u. If you don't mind, I'm going to take this out as 1/2. Is that all right? Take this out as 1/2 like this. You see the 1/2? Negative 1/2 here? So I think it's negative 1/2 du. And therefore we get what? We get negative 1/2 times the integral du over u, which is what? It's ln. Good job. So we get what? Nice. Negative 1/2. Keep talking. Ln of 3 minus 2x plus c. Right? Keep going. Keep going. So let's look at this one. The next one is, find this please. X over x squared plus 1 dx. Is equal to what? I think this one's gonna need use substitution here. So what are you gonna substitute out? Yeah, u equals x squared plus 1 du dx. Yeah, 2x. Can you go to dx from there? What is dx going to equal? Yeah, du over 2x is equal to dx, and if you're doing this right, first we multiplied dx by both sides, and then we divide it out, but just kind of skipping to it now, because I'm hoping on when you see this in class, you'll just be able to take it like this. So substitute, right? So substitute. The x does not have a substitution value, does it? But here we have over u times, if you don't mind, I'm going to do this again. See this 1 here? Half right there. Take that 1/2 and put it out there if you don't mind. And that will give us du over x, won't it? And what happens with these x, this x and this one, Chloe? They cancel. So isn't it true we get this? We get 1/2 times the indefinite integral du over u, which is again ln, so ln of x squared plus 1, whoops, go ahead, plus c. What did I forget here, Dylan? I forgot this 1/2 right here, so let's put it here. Is that alright? This is a lot. How far have we gone? Alright, let's do 2 more, okay? How about this one? X squared over 3 minus x cubed. Is it possible, the x here, is it possible that this is some part of the derivative of this? Seems like there's something missing here, doesn't there? So u substitution, let u equal what? 3 minus x cubed du dx, negative 3x squared du, I'm sorry, dx, du over, can you see the 1/3 there? Don't you go with that 1/3? So I'm going to take a negative 1/3, like this if you don't mind. Negative 1/3, just so you can see it. So I'll take this negative 1/3 here, Chloe, is that cool? Here. And then we'll get, going to do our substitution, x squared over u times du over x squared, the x squareds. Cancel. This is getting good, isn't it? Can you see it? ln, what was our function? 3 minus, like that, plus c. Is that good?